Hi everyone. So today we're going to look at building custom data loaders in the fastai2 framework. The notebook we're going to look at will be available in the Practical Deep Learning for Coders 2.0 repository. If you're reading this from Twitter, I'll leave a link in the Twitter feed along with in the description of this video. And it's a little bit of a different notebook. 90% of the code can be run straight down, which is not something I normally do. But with a comparison experiment like this, it's kind of beneficial to do so. So what we're going to be going over today is building a NumPy data loader. And the reason why I chose NumPy is we can use fastai for preprocessing, and it's a very simple data loader to make. So for the problem that we're going to try and solve, or at least integrate in, it's the adult sample data set. And so we're just going to regularly import, call our path, data frame, the usual stuff that you're used to. If you're used to fastai v1, this little bit right here might be confusing. This is just split by random percent by 20. And then we're going to call a tabular pandas object. Now this is new. It's fastai v2. And specifically what tabular pandas is it's a way for you to pre-process your tabular data set, but not necessarily building all the data loaders. So what this allows is for you to very quickly and very easily grab your raw X's and your raw Y's. So if we look, here's my training data set, because remember we passed in splits. And here's the data frame with our encoded X's, our normalized continuous variables, along with our encoded Y's. And so it's very easy to say convert this over to NumPy, where all we have to do, since it is a data frame, is just simply do to NumPy, and it would convert it right for us. So we're going to take advantage of this and try and speed up fastai data loaders into something that sort of gets away from the overhead. But remember, if you're doing this, you should know how to pre-process your data and not let fastai do most of the magic for you. I've got a few utility functions here that we're going to use. This is specifically going to help with timing, and we'll see why in a moment. Now, most of the timing code is going to be hidden, but we'll show it for this first one. So we're going to use a standard fastai2 data loader. And to generate the timings, we have this very lovely function right here. When you actually go through and look at it, it's not too bad. This just hides all of our outputs. That way I can make it to a pretty string. And then we're timing grabbing the first batch of the training, the first batch of the validation, and iterating over all of the batches in the training data loader and the validation data loader. The reason why we do this is the training data loader is shuffled, and so if we compare the training data loader versus the validation data loader, we can see how long the shuffle function takes. So along with building it for NumPy, we're going to try our best to make this as efficient as we can. So here's the output. Now that should say fastai, that shouldn't say NumPy. So pretend this is fastai2. See, we get about 20 milliseconds for the first batch, more or less, and about 4 for the rest. So that means it takes about 14 to 16 milliseconds for us to train our data. And iterating over all of our batches takes about 700 and 100. And if we take the per batch, it's around 3.5 to 3 1/3, depending on if we're looking at the training or the validation. CPU looks a little bit similar, if not a little bit longer, and that is due to the tensors being pushed to the GPU. That does take some time, and we'll also notice that later. So the first thing we're going to want to do when building a custom data loader is we're going to want a data set to use. Now, for those of you very familiar with PyTorch, you'll understand exactly what we're looking at here. For those of you who are not, get item is how you're going to go through and grab your items from your data set. So this will be, or the __ get item specifically. And this is where we want to return our particular values from our data set from some index that gets passed in. Now the fastai2 data loaders actually pass them in a little differently. So instead of, say, passing in 2 for our index, we'll actually pass in 2 as an array. So we just want to get that first index. Now the reason for that is if I have a batch size greater than 1, say, it'll give me a whole bunch of indices to use instead. So I could very easily just say index here instead of all of this. But grabbing them a batch at a time can make things a little bit more efficient. And also you can see that this is one method where if you were, say, dealing with time series or something where you have data that you want to travel together, this would be exactly how you would do it at the dataset level. And then finally, we need to return a length for our dataset. So that could be self-cats, self-const, or self-wise, whatever we choose. And then we can simply build a training dataset and a validation dataset by calling tab dataset, pass in the train and the validation. Now the data loader itself is where things are going to get a little bit different. It doesn't look like a PyTorch data loader because it's not. It's a fastai data loader. And so what that entails is if we go through, I'm going to go ahead and open up some source code for us to look at. So if we go to fastai2 data and load, this is where the data loader lives. And we can see it inherits this getAttra class, but if I highlight over it, it doesn't tell me where it lives. The reason is it lives in fastcore. Fastcore is sort of the base library for fastai2. It's where it hides a lot of the sort of nitty-gritty code that doesn't necessarily relate to what you want to do in the library, instead just sort of foundational code. And specifically, I want to say it lives in foundation. Yes, so if we look at class get attribute, inherit to have all of your attributes accessible in self _ extra, passed down from the default. So that's this default. That's all it's really doing. But let's now go back to our data loader class. So in of itself, this data loader acts exactly the same way as the PyTorch data loaders, specifically in how you get the data and how you generate the data loader. What changes is how those happen in the background, and that's due to how fastai does their transforms. So there's a few new functions here that you'll notice, like we have create item, create batch, a few different other ones. We're going to look at a few of them today. If you guys find this helpful, I could possibly look into doing a transform data loader where we can look at, say, images or text instead of just tabular data, because then you deal with the transform pipelines, whereas here we don't augment. So the first two we're going to look at is create item and create batch. Now create item will get some index to use, and usually you'd want to return one item from your data set here. And then create batch does exactly what it sounds like. We take some items, create some batches, and then return said batches. So if we go look at the original, you can see that we have an iterator in the data set, and then we have samples here, and these samples represent what we want to go grab specifically. So some amount of indexes will grab from the data set, perform any items, and perform any batch augmentation we want to do, but we don't care about that because all of our particular items are already built inside of our data set. And we'll go through where this self batch size comes in a little later. Or actually, sorry, just a moment. Now, the next thing we want to do is say on create batch, I want to just immediately grab my categorical continuous and our y's from an index in my data loader, and then just return some tensors. So this is technically our entire data loader. So if we go ahead and try this, now we don't have a shuffle function in here, so the shuffle function will not work. We're gonna have to build our own, but for now we're gonna go with shuffle off. So it acts like a validation data loader. I can make it into a set of data loaders by calling the DataLoader superclass, and then I can run our little script that we had earlier. And if we look, this should say fastai, or sorry, no, this is right, it does say numpy. We get about, if we look at the validation specifically, because that's kind of what we're mimicking, less than a millisecond per batch on the first, and then about 0.15 milliseconds per batch over the validation. We go back to fastai2, it was 3.3. So we've already smoked what fastai2 does. Now, the reason for that is we're getting rid of a lot of the overhead fastai has. And so you lose a few of the pipelines and other materials that fastai has available, but that's not a bad thing if you set up your data loader to take advantage of that. Because with having a library as feature extensive as fastai is, it's a balance. And so we're sort of getting rid of some of that balance to give us a little bit more speed. But it's also more, I wouldn't say challenging, but definitely more user intensive, and you should know what you're doing when you're doing this. So we have the validation data loader that's going pretty fast, and the training data loader along with it, but we still need a few things. So we're going to need a way to shuffle our data. Now, normally the shuffle function looks something like this, where it's just random.random. It'll give you some indexes to use when you do random sample. And so whenever you call your data, it'll just pass in this list of indexes that's equal to the length of your data. So remember back when I said that our getData function can sometimes return a list of indexes? This is what I described. So this list of indexes is that shuffled index array from our data. But we don't want to do that. I want to shuffle my data beforehand. Instead of I want to shuffle the internal data set, not necessarily how we grab the data set. And this will allow us to shuffle a lot faster. That's why we have this self batch size down here, and we just return the batches at a time. We're going to set self batch size in the data loader class, which you saw right here. So we don't have to worry about sending it to the constructor or anything. And we'll see just how fast that truly will make things. So let's go back to the shuffle function. Now, instead of doing this random sample, pass in some indexes and whatnot, we're going to use NumPy's random permutation to get a list of indexes and then just reorder our continuous and cats with those index orders. And this can allow us to speed things up quite a bit, which we'll see in a moment. Along with that, we want to change what get indexes looks like. to where it's the length of the data set. And we pretty much never want to, or sorry, we do. And if we want, there is something missing here, my bad. If we wanted to, say, shuffle the data set, this is where the shuffle function would come into play. So all we have to do here is if shuffle self.shuffle function. And then if we have our data loader shuffle, it'll go ahead and shuffle things for us. Now the other thing you'll notice is I'm using this @patch. This is something from fastcore. And what this allows us to do is essentially pass or patch on functions to already described classes. So here I'm saying for the tab data loader class, that's what my input's going to be. I'm going to attach this to the tab data loader. So it's going to replace self. So I could have like tab data loader and then, X, Y, Z if I wanted other variables to go along with it. So now that we have a way for us to shuffle our data, we basically have everything done. So at the bare minimum, when you're going through and adjusting this, you need a way for you to shuffle your data that you know will work. You need to pre-process your data yourself, and then you need to take that pre-processed data and then just simply convert it to tensors as it would expect. And you can do that via either create item or create batch, depending on what you want to do and how you want to go about doing it. So now that we have all of that out of the way, let's sort of go through the final timings. So I'm going to go ahead and run the actual code again, because when I ran it the first time, I had that particular issue. So we're going to let that run real quick. This should be self.shuffle. That's why we have that issue, which is not self, it's X. If those of you get confused by that, I'll get confused by it too. It's definitely something you have to get used to, but once you do, you're pretty okay. And actually, give me one moment here. All right, sorry about that. I realized I had made a slight mistake, along with where I was trying to set up the shuffle function to make everything work properly, which this is very important, otherwise you won't shuffle your data. With our particular script, if you stop it, it's redirecting where the print function goes to, so I had to change a few things. So upon rerunning our code again, the first is going to show our numpy, the second is going to show our fastai2 data loader. They have the same device, they're on the same batch size. And so the first batch in our training data loader took 18 milliseconds here, almost 19, versus our data loader, which took 2.5. And if we boil down to it, the absolute worst was about 4.5, which means shuffling took somewhere between 2 to 3 milliseconds, compared to fastai2, which took around 15. So we already sped it up there. And then if we look at grabbing all of the batches, we take it from almost 700 down to a measly 30 to 40. In the training data loader and the validation data loader, 163 to 7. But most importantly, the time per batch overall went from 3 to about 0.15. And then if we ran the same thing again for the CUDA implementations, which the bottom should say CUDA, I think I just simply, let's do DOS f.device equals CUDA. My apologies. If we looked at those final timings on the CPU and the GPU, we can notice that it's a lot lower. So this is in general a way for you to build your custom data loaders in fastai2, inheriting from a data loader class that in my opinion allows a lot more freedom and makes conceptually a lot more sense compared to the sort of hand tying that PyTorch can give you. And especially it makes sense for those of you who are new and trying to get into this, because the names all make sense with how the fastai2 library works. So thank you guys for joining me today and watching this video. If you have any questions, feel free to reach out to me on the forum. I'm going to start a thread specifically for this tutorial. So feel free to reach out to me there, reach out to me on Twitter, what have you. But thank you guys for watching.